Hey guys, so I'm going to create this video today really quickly to show you a couple more dimensional analysis practice problems. I'll try to reinforce significant figures and scientific notation in here as well, and I'll also talk a little bit about density, which I didn't talk about the other day, but I want to tell you a little bit about the interface first. For starters, you'll see I'm going to do most of the writing here. It's going to show up as ink as I do the writing here. I'll use the pens and I'll try to highlight things as the semester goes on and so forth. And then over here, you'll see that this is just a calculator that I'll use to show you how to do the calculations at the same time. Hopefully between these two things you can follow exactly what's going on. Let's go ahead and take a look at this first problem. We've got if 1 milliliter of ink can print 50 pages of text, how many pages could be printed with 1 gallon of ink? Okay, so when we read this question, immediately we know that we're going to start with the 1 gallon of ink. That's the question. How many pages could be printed with 1 gallon of ink? When you look at this, you can see that this has two significant figures. So that means that our final answer will have two significant figures in it as well, and we'll work our way through it that way. So we're going to start with our 1.0 gallons of ink, and we'll put that over 1, because we always start with what we know and put it over 1 if it's standalone. Now there might be some times where we'll start with a rate or a conversion factor, in which case we'll take a look at how those are going to work out in just a few minutes. I have one example like that. Okay. Now the first thing we need to be able to do is we need to convert our volume measurement of gallons into some sort of a metric measurement. In this case, we're looking for milliliters to use. So when we do that, what we know is that 1 gallon is equal to some number of liters. It's 3.79 liters, and that can be looked up on the internet. Your gallon unit will cancel at this point. If you stop there, your answer would be liters. That's only somewhat helpful to us, so we're going to take the fact that 1 liter is 1,000 milliliters, which is a little bit more helpful to us. You can see now that your 1 liter will cancel, or your liter unit will cancel. You're left with milliliters. And now we can go back up here when we realize that 1 milliliter, this idea that 1 milliliter is worth 50 pages of text. Okay, we can come back here to recognize that for every 1 milliliter, we're going to have 50 pages that we can go ahead and print out. Okay, so now we can go over to our calculator and we can figure out what this actually is going to work out to be. So what we're left with is 1.0 times 3.79 times 1,000 times 50. We can see that it works out to be 189,500. So for now, let's go ahead and write that whole unit down. We got 189,500 pages. But like I said, we only want to have two significant figures. That means we want to round it to the second significant figure right here. Okay, we want to round that 8. We've got two options. This can either round to 190,000 pages, which is two significant figures, but because that number is really large, we might consider putting it into scientific notation. 1.9 times 10 to the 5th pages, okay, which would be appropriate as well. Remembering that only one digit goes before the decimal. We only count these here when we're counting significant figures. And this times 10 to the 5th tells us how many places we would have to move it to placeholder. Okay. Next example. We've got a patient in a hospital, and that patient is being given intravenous fluids that must deliver 1,000 cc's of dextrose over 8 hours. The intravenous fluid tubing delivers 15 drops per cc. What is the drop rate in units of drops per minute that must be administered to the patient? So when we read this question, we've got a few things immediately that stand out. First of all, we can see 15 drops per cc. Okay, that is a rate. You can see that the two units are related to each other. That's important because we might be able to use that, or we will be able to use that as a conversion factor. We can see that drops per minute is the desired endpoint. Okay, so what that means is our final result, our final answer should be some number of drops per minute. So everything that we're going to set up must cancel out so that we're left with drops per minute. Finally, we can see that we've got 1,000 cc's over the course of 8 hours is what that patient must receive by delivery method. So that tells us immediately that that's what we're starting with. So this is one of those situations where we're going to start with a rate of 1,000 cc's for every 8 hours. So I want you to notice we're starting with a rate of volume, or we've got a rate that's measured in volume per hours, cc's per hours, and we're trying to get drops per minute, okay, which is still amount per time, amount per time, amount per time. So what we need to do is we need to independently convert our cc's into drops, and we need to convert our hours into minutes. Okay, so let's go ahead and start with the hours first. That's the most straightforward. We know that 1 hour is equal to 60 minutes. So now your hour unit's going to cancel. Now if we stop, we're left in cc's per minute. We're looking for drops per minute. So we're in the right wheelhouse here. Minutes is in the denominator. Now what we need to do is we need to convert your cc's into drops, and that's where this conversion factor comes in here. We know that there are going to be 15 drops for every 1 cc. So now your cc's cancel, okay? And you can see that we're left with a unit of, oh, no unit here, oh, inverse minutes here, and drops. So we're left with drops per minute, okay? So now when we work our way through this, it's 1,000 times 15, which is 15,000 drops per 8 times 60, which is 480. In the case, we have minutes here. So we're left in drops per minute. Now we just go ahead to our calculator. We want to go ahead and work it out. 15,000 divided by 480. And what we're left with is 31.25 drops per minute. So we have 31.25 drops per minute. Well, the problem with this is that we've got 4 significant figures here. You can see with the values that we started with, we had 1 significant figure here, 1 significant figure here. That means we should have 1 in our final answer, which is going to give us a rate of 30 drops per minute. Okay, so the biggest thing to think about here and remember is that we started with a rate, we ended with a different rate, and we needed to convert each of those units that made up that rate independently to give us that final answer. Similarly, we had 1 significant figure to start. We want to make sure we have 1 significant figure to end with. The last example is a little bit more of a doozy, but I like this one for a couple of reasons. Mostly because it allows us to string a lot of units together, but also because it allows us to talk about density. Density, as we spoke in class the other day, is a relationship of mass of substance, whatever that substance might be, divided by volume of substance, whatever that volume might be. So there's some mass of substance will always displace some amount of volume, and it's a physical property of a substance, which is called its density. Okay, so we've got a 5-gallon container of water. And when I carry a 5-gallon container of water from my car, I always wonder its weight. It's pretty heavy. I do some training and things like that, and while I'm not necessarily carrying it to my car, I do carry large amounts of water all over the place for some of my own personal training. I looked up on the web and I found that 1 pound is equal to some huge number of kilograms, 0.453542 kilograms, and 1 quart was equal to 0.946353 liters. Calculate its weight in pounds. So we're starting with a liquid measure, a volume measure in gallons. We're trying to get to a weight measure, okay, in pounds. So it should make sense immediately that density is going to have to come in here at some point in time, because we're going to have to be able to convert our weight, convert from our volume into our weight. So we're going to start with the fact that we've got 5 gallons of water, okay? I'm going to go ahead and carry the fact that it's water in here for a couple of reasons. Okay, first of all, it's a good habit, but second of all, that density thing is going to be important. First things first, we want to make sure we can convert our liquid measure of gallons into something that we can use with respect to the density. Okay, so what we know is that 1 gallon is equal to 4 quarts. Okay, 1 gallon of water is equal to 4 quarts of water, or anything for that matter. It doesn't have to be that. Okay, so we're going to cancel that out right there. So now we've got the 4 quarts. Now we can say that for every 1 quart of water, you're going to have 0.94633 liters of water. And you can see that the quarts of water will now cancel. Now here's the thing. Density is measured in mass over volume. Well, the density for water, it's a physical property of water, is equal to 1.0 grams per 1.0 milliliters. It's a really useful thing right there. So we need to convert our liters into milliliters. So what we know is that 1 liter of water, or again anything else, is equal to 1,000 milliliters of water. That cancels your liters unit. Now we were able to get it in an appropriate measure right there that we can work with. Now the problem is we've got to convert our volume into a weight or mass measure. That's where density comes in. We know that for every 1.0 milliliters of water, you're going to have 1.0 grams of water. That's going to cancel that out right there. So now we've got it into a measurement for weight. Now it's a situation of we convert our grams into kilograms. 1,000 grams is 1 kilogram, okay? And then finally, that very last conversion factor shows us that for every 0.453542, see if I can fit it in here, kilograms is equal to 1 pound. So now your kilograms cancel, okay? And then these grams canceled over here as well, all right? So we have a whole lot of stuff going on here. This is a prime example of why we'd want to make sure that we simplify our entire numerator first, simplify our entire denominator second, and then simplify the entire thing altogether. So let's go ahead and work our way through this. We end up with 5 times 4 times 0.946353 times 1,000 times, in this case it works out to be 1.0 times 1 times 1. So we'll go ahead and stop there. And we can see that it is, the numerator works out to be 18927.06 pounds over, now we'll go ahead and work on our denominator. 1 times 1 times 1 times 1 times 1, that's 1, times 1,000 times 0.453542. 0.453542 equals, and we could do this in our head, equals 453.542. Sorry about that. Now we can go ahead and perform this conversion right here. We're left with 18927.06 divided by, whoops, in the wrong screen here. Sorry about that. Guess I'm a newbie at this here. Go ahead and get rid of that. Come back over to here. 18927.06 divided by 453.542 equals. And we can see that the unit works out to be approximately 41.7316581 pounds. Okay. Now when we start here, you can see that we only have one significant figure with what we started with, so therefore we only need one significant figure when we end with, so therefore it's going to be about 40 pounds. Hope you found this helpful, and I wish you the best of luck as you work your way through them.